Hey, what's up everyone? I hope you're well and keeping safe. In this video, I'll solve and explain the LeetCode coding interview question to find the first unique character in a string. This question was asked by multiple companies such as Amazon, Apple, Facebook, Google, LinkedIn, Microsoft, etc. during coding interviews. As the title suggests, we need to find the first non-repeating character in a string and return its index or position in the input array. I'll explain 3 approaches so you get a good understanding and are able to pick the right approach based on the constraints. I'll talk about a follow-up interview question and I'll explain how to answer it. By the end of this video, you'll be well equipped in case this question pops up during your interview. So let's get started. Let's use the string as an example. First one is using a HashMap or dictionary to store occurrences of characters. Because the HashMap allows us to store key value pairs, we can use it to store the character as the key of the HashMap, and the value would be the number of times that character occurs in the input string. So let's build the HashMap using the input string. We first loop through the input string starting at index 0 and we find the letter A. We check in the HashMap and we don't find the letter A in the map. So we insert letter A in the map and set its number of occurrences to 1. We move on to the next index, which is 1, and we find a B. We check in the HashMap, and since B doesn't exist in the HashMap, we'll insert it for the first time with the number of occurrences as 1. Moving on to the next index, it is A, and this time when we check our HashMap, we indeed find the character A, and we simply update its occurrences by 1. So the number of occurrences for A is now 2. And now it's time to find the first unique character in the input string. So we start looping through the input string once again, starting at index 0, we get an A. We look up the HashMap to get the number of occurrences for letter A, and we see that it has occurred 2 times. This means that the letter A is not unique. So we skip that and move on to the next index, which is 1, and the letter is B. Moving on, the next index is 3 and the letter is C. We look up the HashMap and we see that there is only 1 occurrence of the letter C, and therefore C is our first unique character in the string, and we need to return the index of C, which is 3 here. So this is how we can use a HashMap to find the first unique character in a string. Now in the first approach, we saw that we had to iterate the input array for the second time because the HashMap does not preserve the insertion order. In the second approach, we will use a LinkedHashMap if you are using Java, or an ordered dictionary if you are using Python. A LinkedHashMap allows retrieving keys in the same order that they were inserted in. We loop through the characters in the input string and populate the HashMap as follows. If the character key does not exist, we will insert it with a value equal to the index of the character. If the character key does exist, that means it is not unique, and we will set the value in the map for this character to null. We can also set it to -1 if you prefer. Finally, we will loop through the linked HashMap itself and return the first value that is not null. We will start iterating the input array at index 0. Now as we iterate through our input string, starting with index 0, we get the letter A. We check if the letter A exists in our HashMap. Since it doesn't, we insert the letter A as the key and we insert its index as the value. We go on to the next index, which is at 1, and we get the letter B. B doesn't exist in the HashMap as well, so we insert B and we insert its index, that is 1. We move on to the next index, which is index 2, and we see that the letter is A. We check in the HashMap if the letter already exists, and in this case it does exist. Therefore, we will erase the index and we'll set it to null. The next index is 3 and the letter is C, and we'll check our HashMap, and since it doesn't exist, we'll insert C and its index 3. Moving on, we'll check our HashMap if the letter B exists. Now in this case, it does exist, which means that B is not a unique character, so we'll store a null. Moving on to the next index, which is 5, we get the letter D. We check our linked hash map, and this time D doesn't exist. We store D as the key and its index 5 as the value. At this point, we have populated our linked hash map. We are ready to find our first unique character in this string. To do that, we will iterate through our linked hash map itself till we find the first key with the value which is not null. As soon as we find the value which is not null, that is our first unique character, and the value is the index which we need to return. Now let's iterate through our linked hash map. The first letter is A, and we see that its value is null, which means that it is not unique. So we skip it and move to the next letter, which is B. Again, we see that its value is null, which means it's not unique. We skip that one as well. And next one, we have a C, and we can see that its value is not null but a number 3, and this is the index of the first unique character in our string. Both the previous approaches work fine, but the linked hash map approach will be slightly faster as we do not need to iterate through the entire string again. But overall, the previous approaches are a tad slower due to the usage of the hash map. Given we only need to worry about the lowercase English letters, which are 26 in total, we can store the number of occurrences in an array of size 26. Let's call it reps, short for repetitions. To be able to use an array to store occurrences, we need to map the alphabets to an index or position into the reps array. For this, I need to show you the ASCII chart, which will help understand how we can achieve this. The ASCII chart allocates an ASCII code or a number for every character in the English language. If you observe the first row, the ASCII code for the alphabet A is 97, and the ASCII code for alphabet B is 98, and so on. So if you look at the alphabet A as a number, it is 97, B is 98, C is 99, and so on. Now subtract 97 from each alphabet. A minus 97 will give us 0. B minus 97, which is 98 minus 97, will give us 1. C minus 97 will be 99 minus 97, that is 2. And finally, Z minus 97 will give us 25. Notice that the result of subtraction is leading us to the indices into the reps array. We can store the number of occurrences for alphabet A at index 0 of array reps, the number of occurrences for alphabet B at index 1, the number of occurrences for the letter C at index 2. The next question is, how do we keep track of the number of occurrences of every character in the input string? Now let's say we want to find the index of the character C in the reps array. We can get the index of C in the reps array by subtracting 97 from C to get 2, and then we will increment the value at this index in the reps array. The array reps will be of size 26 to store the occurrence of each lowercase alphabet in the English language. We will start iterating through this input string character by character. First, the character A. Now we need to find the index of this character in the reps array. For that, we will do A minus 97 and we get a 0, and we'll increment the occurrence of A by 1. To update the occurrence of the alphabet A, we need to first find the index for the alphabet A in the reps array. The index will be the alphabet itself minus the number 97, and this is of type integer, and this will give us 0. We will increment it by 1, and so if we represent these as index and value, for index 0 we'll store the value 1. The next element in the input array is B. Now its index is B minus 97, which is 1 here, so we'll update the value pointed by the index 1 in the reps array, which would be reps of 1 plus plus, so that would make the value at index 1 equal to 1. Remember that all the values will be initially 0 when we define this reps array. The next alphabet is the letter A, and we'll get the index of this letter A again, which is 0, and we'll update the value by 1 using the plus plus operator, which will make this value 2. Proceeding in the same way, we will set the number of occurrences for character C to 1, and we will update the number of occurrences of character B to 2. The last element in the input array is D. Let's find its index here. from the ASCII chart. D has an ASCII code of 100. So 100 minus 97 is 3, which means we need to update the value at index 3, and therefore we get 1 here for index 3. As the last step, we need to iterate through our input array again, and for every element find out what the number of occurrences are in the reps array. So we'll start off with index 0. The character A will have the index 0 using this calculation. We look up the value at index 0 and we find that it is 2. So that means the alphabet A is not unique, and we'll skip that. We'll move on to the next index, which is index 1, and we get the letter B. We'll map the letter B to the index in the reps array and we get a 1. We look up the value in the reps array at index 1 and we see that it is 2, which means that the letter B is not unique and we skip it as well. The next index is 2 and the alphabet is A, and the alphabet A maps to index 0 in the reps array and we will skip it because its occurrences is more than 1. The next index is 3 and the alphabet is C. We'll now convert the letter C to the index into the reps array by subtracting 97 from it. We'll get the index 2 and look up the value at index 2 and we find that the index contains the value 1, which means the alphabet C occurs just once, and this is our first unique character in the string, and we now need to return its index. And this is the third approach to solve this problem. Now out of the three, which approach do you think is better and in what scenarios? Let me know in the comment section. If we have the constraint which says the input consists of only lowercase English letters, the third approach using reps array is the best as it is the fastest. As a follow-up, the interviewer might remove this constraint and allow uppercase and lowercase letters in the input. Now the reps array approach is not flexible because it relies on the ASCII character codes being in sequence to find the offset into the reps array, and this approach won't work when both uppercase and lowercase alphabets are allowed, as they aren't sequential in the ASCII chart. In this scenario, the LinkedHashMap is the best option as it will work with both uppercase and lowercase alphabets. Okay, I'm going to code up the solution now using the LinkedHashMap, and following that I'll code up the solution using the array to store occurrences, and then we'll see which one is faster. We will do some validation on the input and check if the input string is blank, and if it is, then we'll return -1. Now we'll define our LinkedHashMap, and the key of this LinkedHashMap will be the character and the value will be the index of the character. Now that we have stored all the unique characters and their indices in the linked hash map, let's iterate through this hash map and get the first value, which is not null. If we have finished iterating through our linked hash map and still haven't found our unique character, we simply return -1. Now let's run this code. Now let's implement the approach using the array to store the occurrences of the characters. I'll define a new array called reps of size 26, and in this array we will store the number of times a character occurs. We will iterate through the input string. We will grab the current character and we'll subtract 97 from it, and that will give us the index or position in this reps array, and we'll use the plus plus operator to increment its occurrence. Now we'll go through the input array again, and for every character we'll get the occurrence for that character from the reps array, check if it is 1, which means we have found our unique character. As soon as we find that, we'll return the index. If we finish iterating through our input array and find that we do not have any character with number of occurrence equal to 1, we'll return -1. Okay, here we can see that the second submission has a runtime of 14 milliseconds, which is less than half of the first submission. I hope you found this video useful. Please do subscribe for more content and remember to like and share this video. Thank you.